Linking back to where we finished off earlier. Evaluate the integral between 2 and 1 of 4 cos t 3t dt. What's the important thing here to remember? Yeah, angles, sine and cosine functions, angles for calculus must be in radians. So the integral of 4 cos 3t is, we'll put it in our square brackets, 4/3 sine 3t. We needn't put the plus c because we're doing a definite integral between 2 and 1. Yeah? Yep. What, leaving the c out or putting it in? No, you do always leave it out for a definite integral because they cancel. Yeah? So if you've got limits, you can leave the plus c out because you're integrating it to put in square brackets and evaluate.
You can leave it out from the start,
Yeah, you can leave it out from the start, yeah. All right? And then what we do is put in values, so that is equal to, set of brackets, 4/3 sine of 3 times 2 minus 4/3 of sine 3 times 1. Okay, everyone happy with that? Yeah. And that evaluates to minus 0.5607. Everyone get that answer? Yeah? Okay. On the following page, the first 1a is evaluate between 2 and 1 for e to the 2x dx. If we go back to your table, because we haven't used the e to the power of 1, the integral of e to the ax is equal to, sorry, we need dx in there, is equal to 1/a e to the ax plus c. So that's the method here. Yeah. So a in this case, in our problem, is 2, isn't it? Yeah. So we got 4/2, which is equal to 2 e to the 2x between 2 and 1. Everybody follow that? 2 comes down under there and 4/2 is 2, yeah? And then we just simply put in the limits. So equal sign there, equal sign there, 2e to the power of 2 times 2 minus 2e to the power of 2. And the evaluation of that is, find it in the paperwork, 94.42. That evaluates to. Plug that in the calculators and just make sure. Has anybody had a go at the next one? Yep. What answer did you get, Catherine? Final answer. Well, you have gone wrong somewhere then. Yeah. This one, I'm going to put it on another page. This one is an interesting one. We're looking for the integral between 4 and 1 of 3 over 4u du. Which entry in the table is relevant to that problem? One over x, yeah. This is the relevant entry. The integral of 1 over x is equal to ln x. Just see. So how can I rewrite that so I've got 1 over something? And then I can use that entry in the table. What's the constant in terms of u? Can I not write that as integral between 4 and 1 of 3/4 times, meant to be a dot, I'll put brackets around it if you like, times 1 over u dx. Yeah? And now I've still got the same thing, haven't I? Yeah? But what does that mean I can do with that 3/4? Take it outside, yeah. So I can go is equal to 3/4 of the integral between 4 and 1 of 1 over u du. Everybody still following so far? Now when we write the definite, the integration out in the indefinite integral form, we need to put 3/4 outside our square brackets, and then the integral of 1 over u is ln u, and that's between 4 and 1. And lastly, the final bit before we actually use the calculator is 3/4 outside some big brackets, ln 4 another set of brackets, minus ln1. Close those brackets, close the big brackets, because it must be 3/4 times both of those two. Plug that in your calculators. The answer you should get is 1.040. Is that the answer you get? Yeah, good. Right, in the notes as I've given you, there are a number, again robbed from the Bird book, there are a number of indefinite integrals of the types we've been looking at, plus some that include square root kind of functions that you can have a go at. Remember, what you need to do there is get those in indices form, so they are in the form of ix to the n, and then integrate. So there are ones that you can have a go at. Let me know if there's any particular ones you've struggled with, and perhaps we can have a look. And then a little bit further on, there are some indefinite what to do now. Second set of have a little bit of a look at this integral calc.